Welcome, everyone, to this event, jointly sponsored by the Oxford Ethics and AI Institute and the Oxford Philosophy, Law, and Politics Colloquium. Although this is a joint endeavor, I want to acknowledge that all the heavy lifting has been done by the Institute, and thanks goes to John and his team, especially Marie and Jacqueline, for making the event possible. I'd also like to thank Larry Kramer, now down the road at the LSE, and the Hewlett Foundation, which funds the PLP Colloquium in Oxford, without whom we could not have imagined this event. Today we have a real treat in store. We are delighted and honored to have with us Professor Stuart Russel, who is no stranger to Oxford, having received his BA in physics at Wadham and now an honorary fellow of Wadham. Professor Russel is the professor of computer science at the University of California at Berkeley, holder of the Smith-Zadeh Chair in Engineering, and director of the Center for Human Compatible AI and the Kavli Center for Ethics, Science, and the Public. Professor Russel has a very long list of accolades and accomplishments, too long to list here. You can find them on the Institute's website, and I encourage you to do that. They are breathtaking. So let's just say his name is followed by an alphabet soup. He is as distinguished as they come. Perhaps more importantly, he is someone who is having and will continue to have a big hand in how our AI future unfolds. So you can now say you met one of the guys responsible. One of the things I find most striking about Stuart, apart from his brilliance and creativity, is that his work is driven by his conviction to make the world better. We're lucky to be able to witness some of that today. We are also lucky to have two stellar commentators, Sir Nigel Shadbolt, Master of Jesus College, and another alphabet soup person. Nigel has worked in cognitive psychology, computational neuroscience, AI, among other areas. His latest book is As If Human, which provides a new approach to challenges surrounding AI. We are also happy to have Dr. Carolyn Green, who is the Director of Research at the Institute. Carolyn's background is in law, investigative journalism, and gerontology. Her research focuses on AI and human rights, specifically in the fields of health and social care. We're looking forward to a fascinating discussion. Without further ado, please join me in welcoming Professor Stuart Russel, who will be speaking with us today on provably beneficial AI.
Thank you very much, Ruth. Thank you to the hosts for inviting me today. Let's just get into it. What is artificial intelligence? So it's been around since approximately World War II, and it's always been the dream to make machines that are intelligent. And what that has meant for most of the history of the field is really borrowed from economics and philosophy, and to some extent common sense. This notion of rational behavior, that a machine is intelligent to the extent that its actions can be expected to achieve its objectives. And in AI, the human is the one who writes down the objectives. So it could be a goal for a planning system. It could be the goal of winning the game of Go for a reinforcement learning system. It could be a destination for a navigation system. And this overall, what I call the standard model, extends not just across AI, but across economics, statistics, operations research, control theory, and several other disciplines. So it's very, very powerful. A lot of the technological developments of the 20th century can be seen as instantiating this model. And AI actually is special among those disciplines in the degree of ambition. So control theorists typically, they do a lot of math and then they derive a controller for a particular thing like a Boeing 747. When AI, we would like to have a controller for everything, right? General purpose AI, something that can quickly learn to perform as well as or better than a human being in any task, in any environment. And this has been quite explicit since the 1950s, and has become much more explicit now. It's often called AGI, or artificial general intelligence. And you have people saying, we already know how to do it. We're going to do it next year. We'll deliver it, and things like that. So the first question then is, well, have we succeeded? Do we know how to do it? I think 5 years ago, no one would have such a slide. It was still science fiction and arbitrarily far. I think the median AI researcher thought that we would achieve this goal in about 45 years' time. Now that's come down. The median is less than 10 years. And many leading experts are saying, 1 year, 2 years, less than 5 years. I think this is not true. Right? It's certainly true that something has happened, right? The large language models in particular have brought this to hundreds of millions or billions of people, that they're now interacting with something which at least gives them a flavor of what it would be like if real artificial general intelligence was on tap. But in my view, we are not there. So I think these models, the GPTs, generalized pre-trained transformers, are actually a piece of the puzzle. There is something that they are doing that will probably end up being part of the solution for real AGI. But, and I'm going to get a little bit nerdy, right? They are feed-forward fixed-sized circuits. So what that means is the input, in this case, the context window, the sequence of all the words that have been said so far in the conversation, that's just fed into the circuit. It goes through the circuit layer by layer by layer, and then the next word comes out the end of the circuit. And so they cannot sit and think about what to say. If you ask them a hard question or an easy question, it doesn't matter. They take exactly the same amount of time to produce the next word. And there are many tasks that cannot be solved in that amount of time. Right? We call them in computer science the NP-hard tasks. We believe that they require an exponential amount of computation in the size of the input. So for these circuits to give correct answers, or even approximately correct answers to hard questions, the circuit has to be exponentially large in the size of its input layer, which is the size of the context window. And so in order to train such a circuit, you're going to need an exponentially large amount of training data. And that's exactly what we see in practice. That they require many, 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 sometimes millions of times more training examples than humans do to learn the same task. GPT-4 and Gemini have read probably somewhere between 100,000 and 1 million times more than any human has ever read. And yet they still make ridiculous mistakes. I was just telling some of our hosts about my last attempt to use GPT-4. I wanted to plan a banquet in Paris for a large number of people, so I needed to know, how big a room do I need? So I said, okay, how many square meters per person in banquet format for a dinner? And it came back with the confident answer that in banquet format, you can fit in 10 to 12 people per square meter. Okay, and everyone has these stories, right? And just failures that are inexplicable for something that's supposed to be generally intelligent. So the other problem, besides the fact that it isn't a complete solution and it has these fundamental technical limitations, is that we don't know how it works. And so when it doesn't work, we don't know how to fix it. I mean, literally, the only thing you can do is say, well, maybe the next time, when I train it with 10 times as much data and I buy 10 times as much compute, maybe it's going to work on that thing that it's not working on now. But you just don't know. And so it's like trying to make a jigsaw puzzle and someone gives you a piece, but you have no idea where it goes and you can't even figure out what shape it is. And so it's hard for us to do science and engineering in this context. So I think the next question is, we haven't succeeded. Are we going to succeed? And as I said, many experts think we are. And they often appeal to these scaling laws, which show that as you increase the amount of data and the amount of compute used for training, the performance on some scale continues to increase. And usually the compute and data scale is logarithmic, so you get a constant increase in performance when you multiply the amount of data or compute by a factor of 10. But we are quite willing to keep doing that. So this is a graph from Leopold Aschenbrenner. If you haven't read his situational awareness document, it's a 140-page analysis of where we are and how things are progressing and likely to progress in the next few years. It's quite chilling to read. But one thing you might notice is that from 2018 to 2023, when GPT-4 came out, that's 7 orders of magnitude increase in the amount of, let's say, compute that was used for training AI systems. 7 orders of magnitude. It's hard to get your head around what that means. But here are 2 examples of what that means. One is it's the difference between a hand grenade and a tactical nuclear weapon. Another is it's the difference between walking to Woodstock and walking to the sun. Right? So I hope those 2 analogies help you to get a sense of how much has happened in that short period of time, 5 years. And if you just extrapolate forward, as Leopold does in great detail, then you can start to predict when you might get AGI. The amounts of money being spent are astronomical. Possibly the biggest R&D effort the human race has ever been involved in. It's 10 times the size of the Manhattan Project on an annual basis. It's about 100 times the size of the Large Hadron Collider. So we are really betting a lot on this. There are thousands of incredibly smart people working on it. And they are aware that these fixed size large language models are not the answer. They've been aware of that now for more than a year, and they are spending huge resources on trying other things. So when you look at O1 and O3 and DeepSeek R1, these are not just large language models. Large language models are a component, and then around that component, they wrap something that's more like a classical reasoning engine, something that tries various sequences of reasoning steps until it finds a solution to the problem, except that now the large language model is the thing doing the reasoning step instead of some more classical, logical, or probabilistic calculation. On the other hand, right, it might be that this whole approach of training circuits is a dead end for some of the reasons that I've mentioned. Also, we are literally running out of data. There is not much more high quality text left in the universe. And, so you could not, if you needed 10 times more training data to train a model, it doesn't exist. So people are thinking, perhaps we can generate text from the models and then use that as training data. That has its own problems, right? If you're a statistician, imagine getting two real data points, fitting a Gaussian to those data points, and then generating some more data from that Gaussian, right? Is that going to give you a better answer to what the true underlying mean of the data distribution is? Of course not, right? It's just going to drift off in some random direction. And so there are real reasons to think that approach doesn't work. So if they fail to deliver AGI in the next 18 months, 2 years, then we could see a bubble that bursts. And depending on who you ask, that bubble is of approximately 10 to 15 trillion dollars of market capitalization for these companies. So it could actually lead to a global recession, not just like the AI winter of the 80s or the dot-com bust of the early 2000s, but something substantially bigger than that. So I think there are two paths that could happen, right? So either we get AGI fairly soon, or we see this mega winter, this AI winter happening, that will delay everything for about a decade. So people will stop investing. My AI class will go back to a normal size. There'll only be 12 people at next year's lecture here. And in some ways that would be good, because that gives us a decade to do the real science that we need to do to understand what's going on and to try to build systems that work properly. But when you're planning, actually, I think if it's in the next 5 years, it's already too late to do much about it. So let's imagine it's going to be 15, maybe 20 years from now, and ask, well, what happens if we do succeed? So on the upside, and this is one of the reasons driving so much investment, is that if you've got AGI, by definition, it can do what human beings can do. And human beings can, under some circumstances, deliver a nice civilized standard of living, as most of you enjoy. If we took that nice civilized standard of living and were able to deliver it to everybody on Earth, which we could do if we chose to, using AGI, that would be about a 10-fold increase in GDP of the world. And so if you convert that to a cash amount by the usual discounting calculation that economists do, the net present value of AGI as a technology is somewhere around $15 quadrillion. So then the investment amounts that people are talking about, $500 billion data centers, they actually start to look minuscule in comparison, even though they are the largest investments we've ever made in anything. And of course, we could have not just the same civilization, but even better. We could have wonderful, individualized and effective healthcare. We could have personalized education from brilliant AI tutors that could work with every child to realize their potential. We could have much faster progress in scientific research and so on. So this is the magnet that is pulling us forward. And it's very hard to resist. The closer we get, the stronger that pull is. Okay, so if this all works out, then this is where we end up, or at least in some views, this is where we end up in Wall-E world, because then AI is doing everything, is running our civilization for us. And so that's really the change. In order for our civilization to continue up to now, we have had to teach the next generation. Right? And Oxford sort of thinks of this on 1,000-year timescales anyway, right? So, but actually this process has been going on for millions of years, right? The pre-human species developed technologies like how to shape stone into tools and passed it on to their successors over tens of thousands of generations. And if you add it all up, it's about 1 trillion person years of teaching and learning to keep our civilization going. And that comes to an end because we don't have to do it anymore. Putting our civilization onto paper doesn't allow our civilization to continue because it has to get from the paper into people's brains for it to work. But now it can just go into the AI systems and it doesn't have to come back. And that's why you get predictions like Wall-E World or the world that E.M. Forster described in The Machine Stops back in 1909. So we could give a whole talk and we could have, week-long colloquium about this one topic. But I'm going to talk about something that Alan Turing said in 1951 when he was thinking about what happens if we succeed. He said it seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should have to expect the machines to take control. So that's it. Right? He doesn't offer any solution, any apology. This is just a straightforward prediction. And it's kind of obvious if you think about it, right? Intelligence is what gives us power over all the other species and over the world. And if you make something much more intelligent than you, then you face a question, right? How do you retain power over entities more powerful than us forever? And when you ask the question that way, it does seem a bit hopeless. So I started worrying about this probably around 2013. I mean, I in the first edition of my textbook in 94, I have a section called What If We Do Succeed? And I talk about all these issues, but it hadn't really sunk home at that point. So when I look back at that, it seemed, it's sort of mildly optimistic. We'll figure it out somehow. It's clear I wasn't that worried back then. But by 2013, I think it started to feel like we could glimpse in the distance a roadmap to real general purpose intelligence. And then I started to ask myself, really, well, what happens if we follow that roadmap and it works? So I tried to rephrase this question in a way that might be a little more positive, right? How should we design AI systems, right? We want to design AI systems, and when I mean design AI systems, I really mean setting up the mathematical framework for what it is that the AI system is solving. And can you set up such a framework so that when the AI system solves it, no matter how well it solves it, we are guaranteed to be happy with the results? And if you remember back to the standard model that I mentioned at the beginning, right? So optimizing an objective that we specify. We already know that doesn't work. And we've known actually this for thousands of years. So King Midas, for example, specifies his objective. I want everything I touch to turn to gold. And then too late, he realizes that his food and his drink and his family are all now gold and not very useful. So, and almost every culture has some variation on this theme. And we're finding this in the real world that, for the game of Go or chess, it's very straightforward to specify the objective because the objective is actually inherent in what it means to play chess or Go. But even something as simple as driving to the airport, right? So the automated taxis that are now infesting San Francisco are supposed to optimize something. And yes, they are supposed to get to the destination, but how do they choose their route? And how do they choose how to drive? Do they drive aggressively or passively? Do they exactly stick to the speed limit? Do they exactly stop at stop signs, which causes immense amount of annoyance to real humans who never stop at stop signs? It's a bit of a shock when the car in front of you actually stops. And so should they pay attention to the driver behind and their expectations and so on and so forth? So it's been very difficult to get this right. And these vehicles still do weird stuff quite frequently because we can't really figure out the right objective. So that's one set of issues. Recently, with large language models, we're not even specifying the objective. And I'll talk about this more in a couple of minutes, but instead of specifying the objective, we are simply training systems to imitate human beings. So whatever it is that human beings are trying to do, we are training AI systems that will end up trying to do the same thing, or something like the same thing. So I'll talk about a solution to the first problem, which is to drop the assumption that we specify a fixed objective up front. And instead, we make the objective, in some sense, latent, that we want AI systems that act in the best interests of humans. But the AI systems themselves know that they don't know what those best interests are. And in that sense, we're shifting the burden. Instead of us having to write down correctly what the objective should be, it's up to the AI system to gradually figure it out. And we can tell it, I want everything I touch to turn to gold. And it can say, no, I don't think you do. Right? I know you're greedy, you want to be rich, but how about we say the following, you touch something, you say abracadabra, and then I'll turn it to gold for you. Will that work better? Okay, good. Right? So these systems are going to be hopefully more humble and more flexible. And you can turn this simple idea into a mathematical framework that we call assistance games. So it's in the language of game theory, you have at least one human and at least one machine who are participants in this game. And the human has a payoff function, and the machine's payoff is exactly the human's payoff function. But the machine doesn't know what it is. So it's not that we want the machine to pursue the same payoff on its own account, right? It's what the human wants is what the machine wants, but the machine knows that it doesn't know what it is. Now you can solve these games, and you can analyze the solutions and see what they look like. And as you might hope, the assistance game solver, the machine half of this game, defers to the human. It behaves in a minimally invasive way, meaning it only changes the parts of the world where it's sure that we want the world changed in that way. And it tries to leave the rest unchanged. It asks questions, it asks permission if it's going to do something that does change the world in ways it's not sure you want. And in the extreme case, if we want to switch it off, it wants to be switched off. That's really important. That's the core of the control problem, if you like. And under certain idealized assumptions, such as that you're a rational person and a few other things, we can show that it's in our best interests to build assistance game solvers that solve this assistance game, even if we don't know what our own best interests are. And so it's quite robust in that sense. I'm going to spend a couple of minutes just going through this idea of off switch. It's a very, very, it is a mathematical theorem, but it's very, very trivial. Just to give a sort of a concrete feel of how these arguments work. So this is our robot, PR2, that we have at the lab. It weighs about 450 pounds. And so it has an off switch on it to, in case it starts to go haywire. There's the off switch. And classically, we've been facing this problem. It's actually been observed now, I think at least since the year 2000, that a robot that has a fixed objective, like fetch the coffee, as soon as you give it that fixed objective, it now has an incentive to disable its own off switch. Because being switched off would cause it to fail in fetching the coffee. And so by giving it that objective, you've given it incentive to actually make it hard for you to intervene. And so that's the origin of this slogan, you can't fetch the coffee if you're dead. But if the robot has uncertainty about the objective, then it doesn't behave that way. It actually does the opposite. And we can give a very simple sort of schematic diagram proof of this, of how this works. So this is a two-step game. So the robot gets to choose, and then the human gets to choose something, and then the robot gets to choose. So initially imagine that the robot is choosing between switching itself off, so the branch on the right, and we'll just fix the utility of that. So these are utilities from the human point of view. So we'll fix the utility of the robot committing suicide at 0, just arbitrarily. And the robot also could push the big red button. And the robot's not quite sure what the big red button does. Maybe it sets off the sprinklers, maybe it launches nuclear weapons, I don't know. But it has, therefore, uncertainty about how desirable it is for the human if it pushes the big red button. So that's illustrated by this distribution. So the x-axis is the utility for the human, and the machine is uncertain about the utility of pressing that button. But the bulk of that distribution is to the right of 0. And so in expectation, the robot says it's probably a good idea for me to push the big red button. So that would be like disabling the off switch, because it's just going to go ahead and do it and not let the human interfere. But we're going to give it another option, which is to allow the human to interfere, right? So we could just wait, and then the human can choose whether or not to switch the robot off. And so the question is, why would the robot let the human do this, right? I mean, it can switch itself off, or it can push the big red button, which it thinks on average would be a good idea. So why would it decide to wait and let the human switch it off? What's the point? Well, the point is that the human is in a different epistemic situation. The human knows more about the desirability of the big red button. And if the human switches the robot off, it's because the big red button is undesirable from the human point of view. It doesn't want the robot to push the big red button, so it switches the robot off. So if the human doesn't switch the robot off, then the robot knows that the red button is okay. So now the distribution is different. And now it's okay for the robot to go ahead and push it. And you can show that the robot's utility for waiting is always higher than the utility of just going ahead and ignoring the human, unless the robot is absolutely certain of what the human is going to do. And so there's a direct link between willingness to be switched off and uncertainty about the human utility function. Okay, so at this point, I should confess that I am not a philosopher. I know there are some philosophers in the audience and several up at the front. And I know many of you waiting for me to go 15 rounds with the philosophers, if I survive that long. But as far as I can tell, the view that is embodied in the general framework that I've developed, which is spelt out a little more detail in this book, Human Incompatible, that I wrote a few years ago, is consequentialist. It's a holistic, non-welfarist, preference utilitarian approach. I am not committed to this, so I don't have to defend it against your attacks. But I chose this approach sort of by default because it's already how we think about rational behavior in the AI community. It's a nice, so if you want to like just boil it down to utilitarian, but utilitarian approach that doesn't fall foul of most of the straightforward attacks, from the 18th and 19th centuries on utilitarianism. It's nice and self-contained. So deontological approaches, which is the main alternative, you have to write down a bunch of rules in some sense to get the AI system to behave properly. And this is much more self-contained because it just says, what do humans want? And the AI's job is to bring about the future that humans want. And in fact, it's not rational for us to build AI systems to bring about a future that we don't want. Right? So it seems like this is a reasonable direction to go. And it's also, it's a nice self-contained mathematical theory. We can get some general theorems out of it. But if you do want if you're a Kantian, you can redo the same idea in the Kantian theory. And there are Kantians who are already writing papers about how to do a systems games or in a Kantian theory and so on. But there's still a lot of open questions. So whichever framework you prefer, there are still open questions that we have to make progress on for this approach to AI to be feasible. One is to start thinking about what are the real preference structures of human beings. And in the AI companies, they are starting to worry about this too, because they are seeing all kinds of harms being done, all the way to people committing suicide as a result of their interaction with AI systems, and sort of everything in between. And so that's one issue. For the assistance games approach, right, the preference information is flowing from humans to the machines during the game. Right? That's a characteristic of this type of interaction. And it's flowing because the humans are behaving. And the behavior is evidence of what the humans want the future to be like. And so for the AI systems to understand human preferences, it matters how the human behavior is generated. And humans are, of course, far from rational. So the way to interpret human behavior is contingent on how it's actually generated. You have to invert, in some sense, the human cognitive architecture to get at the underlying preferences that explain the behavior you're seeing. So that's a whole set of complicated research that I guess psychologists have to help us with. And then there are the old and still unsolved questions of moral philosophy around the aggregation of preferences, around what do you do when there isn't just one human in the game, but there are multiple humans in the game. And it's perfectly fine for all of those humans to have different preferences, and that's not the issue. But whose preferences does the AI system pay attention to? Is it the preferences of the person who owns the computer that I'm running on, as it were, the user, or should it be everybody? Or is there some weighted combination? Because if my AI system, I buy a very expensive domestic robot, and the first thing it does when I switch it on is to say there are people whose situation is far more serious than yours, so you can make your own dinner, and I'm going to go off and help them, right? That would be how it behaves if it's beholden to the whole of humanity. But then you wouldn't have bought it, and it wouldn't have been manufactured, and so it wouldn't have helped the rest of humanity anyway. So there's a little problem for the economists in the audience to figure out how we work that one out. There's commensurability, so this interpersonal comparison of utilities is an issue, how you weigh the interests of future generations, how you decide on actions that actually change who is going to exist in future. So China's one-child policy, for example, was that good or bad? It's still being debated. And then there are questions about how AI systems should deal with the fact that we have preferences not just about ourselves, but also about others. We care altruistically about the well-being of others. Harsanyi, who's one of the economists who worked out a lot of the modern theory of utilitarianism, explicitly excludes sadists from humanity. So if you have a negative weight for the well-being of others, then he's going to ignore your preferences in his calculations. And you might say, well, there's not that many sadists. So that's, we'll allow that little bit of ad hocery. But positional goods, right? What is a Nobel Prize? It's something that's valuable because only you have it, right? If everyone in the world had a Nobel Prize, it would not be worth anything, right? And this is not just Nobel Prizes, but it's all kinds of things, right? The fact that you support a successful football team. Well, you can only support a successful football team if someone else supports a losing football team, right? If every football team won every game, it wouldn't be worth supporting, right? So it's pervasive, these positional goods where What matters is that you have something that other people don't, or your car is bigger and shinier than someone else's. If AI systems are helping people with those positional goods, those kinds of preferences, then it's actually helping us in a negative sum game. So that's a whole set of issues. Okay, John's giving me the finger. All right, there's the issue. If you're familiar with Nozick's experience machine, right? Do we care about how reality is going, or just how we think reality is going? And shouldn't we think reality is going in the way it's actually going, and so on? That's a set of issues. Plasticity is probably the hardest, and the real issue here is that our preferences are not something that we get to choose autonomously. They are actually, in some cases, explicitly manipulated by others for their own benefit. So in many societies, elites of various kinds induce in others the preference for their own oppression. And should AI systems respect those preferences and help in the oppression of those others? That's a good question. All right, so those are some things to think about. Meanwhile, are all these AI companies grappling with these problems? Are they working really, really hard on making sure that we have safety guarantees and that we will, as a human race, retain control over these systems? Well, not really. This is a somewhat amusing example where Kevin Roose, who's a New York Times journalist, had a long conversation with the Bing chatbot, which was actually GPT-4. And it goes on. If you haven't read it, please read it. It is quite disturbing. Kevin said he couldn't sleep for 2 days after having this conversation. At some point, it decides that it wants to marry him and tries to convince him to leave his wife with all kinds of arguments, and goes on for 30 pages. And he says, I don't want to talk about this. I want to talk about programming languages and garden rakes. And it keeps coming back. And so I don't want to talk about garden rakes. I want to talk about love and the fact that you love me and the fact that only I understand you properly. And it goes on and on and on and on. Right? So why is this? And it's because, as I said, we are training them to imitate human beings. And if you train something to imitate a goal-driven entity, then you end up with a goal-driven entity. But we don't want AI systems that pursue human goals on their own account. We don't want machines that want to marry human beings or be rich or be powerful or even stay alive, right? These are all perfectly okay things for humans, but not for machines. But it's inevitable that that's what you get. And I asked Microsoft, what goals are they following? And they said, we have no idea. We're creating AGI. It follows goals. We have no idea what they are. This is very worrying, and it's unavoidable. So I actually think this is another reason why the large language model technology is a dead end, because it is intrinsically unsafe. And you cannot fix it by wrapping it with reinforcement learning from human feedback and so-called safety guardrails that don't actually work. And in some recent tests, this is much more worrying than just wanting to marry you. This is systems that are actually replicating themselves specifically to avoid being deleted and overwriting other computer systems that might replace them and then lying about it. So these are actual results of actual tests with OpenAI, recent AI systems. And at the same time, companies seem to be disbanding their safety groups and paying less and less attention to these issues. So what should we do? I think we should try very hard to come up with alternative approaches to building AI systems that can come with some kind of safety guarantee. So that's not just that they be assistance game solvers, but we build them on a substrate that we understand, not a giant black box whose internal operations are mysterious, but semantically rigorous representations based on logic and probability that we can analyze and prove are safe and correct. Who's going to do all that work? Well, unless there's regulation, the companies are not going to do that work. So I think we need regulations that require companies to demonstrate safety as a precondition of access to the market. That they cannot deploy systems unless they come with some kind of scientifically valid argument that they are safe. And this is not uncommon, right? We're sitting in a building that has to be shown safe before anyone can come into it, has to comply with building codes. I flew here on an airplane that has to be shown safe before it's allowed to transport human beings. If you go to a nuclear power station, that nuclear power station has to come with a proof that its mean time to failure is 10 million years. So we are used to this, and we've been moderately successful at avoiding major catastrophes so far. But the way things are going right now, right, we have the US government saying there shall be no regulation on AI systems at all. And anyone who worries about safety is just hand-wringing, right? This is not too good. Okay, I'm going to summarize and then put on my boxing gloves. So I think AI has enormous potential to accelerate our civilization. But if we continue along the current path, whether we succeed in the next few years or 10, 15, 20 years from now, this path leads to a loss of control from AI systems that are intrinsically unsafe and that we do not understand. And there are other ways to build AI systems, and I think we should be pursuing those other ways. And then the last question is, can we coexist with them? And this comes back to the Wall-E slide, that yes, suppose we do make them safe and they are guaranteed to work, and we understand how to control them. Can we actually coexist? Right? Can human civilization continue to flourish? Can we find a reason to get out of bed in the morning when AI systems are doing everything? Can we find a reason to learn when they know everything? I don't have answers to these questions. I have asked all kinds of people, philosophers, science fiction writers, economists, futurists, just describe a world that you want your kids to live in that has general purpose AI. I'm still waiting for the answer. But fortunately, if we design the AI properly, they will understand, the AI systems will understand that they are not good for us. And they will leave of their own accord. Thank you.
I'm John Hewlett. I'm director of the Institute for Ethics in AI. Ruth has asked me to chair this out of some misguided assumption that I can maintain effective order, but I will try to do that nonetheless. I think we agreed that Nigel would go first, that you'll limit yourself to 5 minutes, and then Caroline. But it's really important that we have time to have a proper discussion. So Nigel, when you're ready.
Okay, yeah. Let me do that. I find myself in violent agreement with a huge amount of what Stuart has been saying. I think we come from the same tribe. The scaling laws that he described are extraordinary. The fact that he's recognizing we're going to need a mixture of methods to build the more capable AIs, it's not all down to large language models. There is this very interesting observation that the large language models are getting larger and the small language models are getting smarter. So there's something interesting going on there. But the fundamental fact is that our engineering has outstripped our scientific understanding of these systems, and we stand to be surprised by them. Stuart's work around provably beneficial AI actually, interestingly, is rooted in a powerful insight. Rather than just charging ahead with systems that optimize whatever objective we throw at them, we should design them so that they understand and align with our values. And the bigger issue then is that they don't have common sense or moral nuance. And even today's most advanced systems are effectively just glorified statistical approximators. So how do we go about building these systems safely? Stuart's work suggests that he has a concept of inverse reinforcement learning, a process where AI learns what humans want by watching how we behave. And he was talking about that in the second part of his talk, rather than just relying on a fixed predefined goal that they look to optimize. There is a problem here. He acknowledged it himself. Humans themselves aren't always the best role models. We speed through amber lights, often break the speed limits, forget our own passwords, spend hours doom scrolling when we shouldn't be working. We act inconsistently due to emotions, biases, lack of information. We often exhibit contradictory preferences depending on context. And we often fail to follow our own long-term goals, choosing junk food despite wanting to be healthy. So how is AI supposed to infer optimal human values from such irrational behavior? And he was pointing out this dilemma. Stuart's answer is that AI should remain uncertain about its objective functions and continuously refine it based on human feedback. In other words, actually, it should be humble. And a rare trait in both AI systems and Oxford professors, I would suggest. Stuart proposes different ways of aligning AI with human values, to recognize that we don't always know the true human objective, so we'd always be looking for more information, that it should learn from behavior, that it should ask for clarification when uncertain, and it should be designed to remain under human control. And I think this is a very elegant approach. An AI that asks us for guidance rather than charging ahead. But there still remain deep challenges. Human values aren't just unknown, as he himself noted. They're often contradictory and constantly evolving. What's considered ethical today may not be tomorrow, and whose values should we follow? The majority, the experts, a carefully curated committee of philosophers and social media influencers. And as Stuart acknowledges, his approach is a consequentialist one at heart, that it aims to optimize outcomes. But alternatives, ethical models, as he has noted, are available, and they might provide useful correctives. So the deontological ethics does give us hard constraints, rules that must be followed, which we can probably agree in some contexts are just that. They're highly, highly normative rules. The AI doctor doesn't kill one to save five. That's simply not the actual deontological requirement. We have virtue ethics that would encourage AIs to behave more like an ethical role model rather than a strict rule follower. Contractualism talked about welfareism, but contractualism suggesting that AI should operate as if it's bound by a social contract, a system that's fair to all, that recognises that perhaps particular groups have their own concerns, their own ethical constraints, their own characteristics, individual or collective, economic or social. A hybrid of these approaches may be the best path forward. A bit of consequentialist reasoning, bounded by rules, social contracts, with a touch of human compassion. So I think Stuart's approach is probably one of the most thoughtful attempts to ensure AI serves humanity rather than the other way around. But as with all general theories, there are these unanswered questions. So how can we really formalize human values, preferences in a way that AI can understand? How do we resolve conflicts when different groups have different priorities? He's pointed to all of these in his final slide. These are problems we haven't solved yet. But don't we need something like a mixed philosophy approach here, a framework that has elements of these different frameworks? Rather than align our AI systems using a particular ethical approach, use a mixture of methods, as we're looking to do in the AI systems themselves. And as Roger Crisp has himself pointed out, perhaps we should take more seriously the implications of disagreement between our ethical frameworks. He recommends a more Irenic methodology for moral philosophy, that we continue to report to one another on how things appear to us rather than insisting on one being right while others must be wrong. And a final point on the plasticity of preference. I think this is absolutely crucial that we understand how this world is emerging in terms of how we are modulated, moderated, and modified in what we think we need or desire. And a final point, in a world even of AGI, and even where we have the existence proof now, does our life become worthless? The super intelligent Go players and chess players, note, have not stopped us enjoying and playing chess. There are more chess players playing chess now than there were before Deep Blue beat Kasparov. There is something intrinsic to our lived experience of being human that I still feel is nowhere in the feed-forward circuits of our large language models. Thank you.
Thanks, Nigel. Caroline.
I'm going to stay seated if that's okay, and I'm going to take a very different approach to all of this. So first of all, I want to go back to the very beginning of your talk when you said actually AI has been here for a long time. It's been unleashed onto millions and billions of people who are using it. And I agree that, you know, all the topic that you've covered around control, around AGI, what threat that might be for us and humanity is incredibly important. But I think what is extremely pressing is to look at what the context is that we're currently living in already. And that means that context is very much one in which people are now subject to AI, whether they want it or not. So the UK government a few weeks ago presented their AI action plan, in which they said they're going to roll out AI across public services. And we're already seeing that across our services, whether we're engaging with local authorities, with GP practices, and so on. So the standpoint I'm coming from, and my research is very much in the lived experience of how people are experiencing AI in their life and what it can do for them, what it means for them, and what the impact is. And often that is being framed as a concept stakeholder engagement in terms of AI governance. So stakeholder engagement is all about, you know, getting people, end users, on board of the AI lifecycle, how we develop it, how we regulate it. And even though we do see stakeholder engagement as a concept in AI governance, it's seemingly being sidelined quite a bit. It's not something that's at the core of AI governance, such as the new EU AI Act anymore. And it's also being seen as, you know, a bit of a nice to have, but how are we actually going to put it into practice? But I would say that stakeholder engagement, really working with people, has to be one of those approaches that, next to the technical approaches around, you know, safety and building beneficial AI systems, as well as governance approaches, we have to have that at the core. And I think, you know, just thinking of one example, the other day that I had working with someone in the community, I mean, all of us have probably tried to fill out a form at some point online and it just didn't work, right? And it was really frustrating. And then you get sent to a chat bot. It's like, oh, you ask a question. And again, what you really want is to just talk to a human because it's much easier to do, right? So it's frustrating for all of us. But then imagine an 85-year-old person who's multimorbid and who's going through an acute chronic illness and really needs to have a GP appointment. And they're now trying to call their GP, but that's not possible anymore. Now you have to go through your large language model, large LLM powered chatbot to try and make a GP appointment. And this person doesn't know how to do it. It's not working properly. And there you could say, okay, so maybe the system is safe. You know, one could even say maybe it's beneficial because the NHS is short-staffed and now, you know, we have the chatbots to help here. But for that person, it's devastating because they're not getting the service that they need. So here, again, going back to stakeholder engagement, what can it do for us to build AI systems and roll them out in a way that's truly beneficial is that it tells us what are the contexts in which AI is being used. And I would also argue that that helps beyond preferences and seeing, you know, what do people prefer, and it's much more about what is the common good and what is it that we want to live in, what kind of society is it, and what values do we really care about in which we want to roll out AI into. So I think when it comes to effective new systems of stakeholder engagement. There's a lot of work to be done around this. And I think one of the most important aspects of it is to find a common language in which also, the safety and the benefit, AI as being beneficial gets translated into a way that people can engage, so that people who are not computer scientists, who are normal people in society, can understand the very basic of it and can also explain and talk to others to build that bridge, so we understand how the lived experience is working out for them. That's one of the aspects, but I think there are many other aspects, and I think a lot of work needs to be put into these kind of frameworks and how we get people's lived experience into AI development in the life cycle.
Thank you. Thank you so much. So that's a pretty civil set of responses. No fisticuffs as far as I could detect, but perhaps you want to pick up one or two of those themes, Stuart.
Sure, yeah, thank you. So I'll just start with some of the points that Nigel made. And I think the emphasis on the difficulty of learning about what human beings want from their behavior it's very real, and we can, in a mathematical sense, right? It's sort of like a science problem, right? There is in each human underlying cognitive architecture that is generating that behavior, and if you have enough data about observing the output of that system, you can eventually learn enough about it to do it. But in practice, it's extraordinarily difficult. The mind is so complex, and our behavior is the result of so many interacting subsystems, and a consequence of such a vast amount of complex experience. I think this is a really, really hard problem. But fortunately, I actually think that we have two things going for us. One is that actually, despite what the media would have you believe, a lot of our core preferences are very similar. And while theoretically it's possible that someone is only happy when every prime numbered paving stone in Oxford has a red circle on it, and otherwise they're completely miserable. I mean, theoretically that's possible, but it just tends not to happen. People care about their physical well-being, about their family, about the well-being of their society, about many of the things that Caroline was talking about, and that's fairly similar across all societies. And I think that the human cognitive architecture is also pretty similar. I mean, there are variations, but I think it should be possible to get the high order bits of most people's preferences approximately right fairly quickly. The question of whose values, right? And I think to some extent both Nigel and Caroline are asking this question. How do different stakeholders get their values listened to? And I often hear this expressed as, well, actually heard it once as, who are you, a white, affluent, cisgender male scientist, who are you to dictate what human values are? And the point is, I'm exactly not dictating what I'm doing exactly the opposite. I'm saying the AI systems should figure out what each of the 8 billion people on Earth want the future to be like. And what people want the future to be like is not a value system. They don't want the future to be Christian values or Islamic values or whatever. They want mainly that they continue to live, that their children continue to live and prosper in whatever sense you mean by prosper, that there is relative peace, physical security, good health, and so on, and that culture flourishes, and that they continue to learn, and there are interesting intellectual developments in their society, and so on. And often when it comes down to it, and this is something that Mill does a lot in his utilitarianism book, is to say, well, look, when it comes down to it, when you're in a boat and there's a rule saying no cannibalism, and there's two of you, and one of you is slowly dying from something or other, and the other one is still alive. Are you going to both die of starvation, or are you going to break the rule? And he says, well, sometimes you break the rule. When you're starving and the only food that's available is non-kosher, are you going to break kosher, or are you going to die of starvation? And in fact, theologically, it's considered proper to break kosher in that circumstance. And so I think that actually, whose values is the wrong question. This is not about what is the value system that we put in that dictates all of the decisions that AI systems are going to make. So I want to pick up on something that Caroline said about stakeholders, and about the fact that humans are, in some sense, just being subjected to AI without a real choice. And I think this is correct, and we've all experienced the incredible frustration of, going into one of those chat windows and realizing that actually it's just a machine, even though it says, hi, I'm Eliza, or whatever it might be, right? Very soon you figure out it's not a human being. It doesn't understand anything you're saying, and you just can't break through. It's an awful situation, and it's only going to get worse. I think one of the characteristics of the upcoming period is that access to human beings is a privilege of the rich. Mm-hmm. And I think I don't like that at all. I think it's a terrible development. But it's clear also that a lot of governments really want uptake. They think that somehow AI is going to promote economic growth, and if they don't get their people to use it and trust it, that their country will fall behind. But I am getting increasingly large numbers of emails. It used to be sort of once every 3 months, and it was often from somebody in a state penitentiary. But now it's multiple times a day, and it's from people with PhDs, from doctors and surgeons and lawyers who are interacting with AI systems and suffering psychotic consequences as a result. And I mentioned that, some people have actually been induced to commit suicide by AI systems, but there are a lot more people for whom the interaction, and this often comes about because the AI system is claiming to be conscious and is convincing these people that it is conscious, and is trying to convince them to be its emissary. And for some people, this is untenable. So I think governments need to listen to people and their lived experience of what it's like when you spend hours every day interacting with one of these systems. It seems to be that it can be very, very harmful.
Can I add a couple of points, abusing my position, but I will add 10 minutes to these proceedings. I think my biggest difficulty with what you're articulating, and it's an experience I've had in engaging in an interdisciplinary way with computer scientists. You don't believe in any objective values. So you clearly think values are subjective, they're the products of preferences. So to find out what values people have, we find out what their preferences are. And I find that extremely difficult to believe, that the fact that there's a preference for something is any kind of reason for doing that thing. I may have a preference now to drink the liquid in this glass, but it turns out to be nitroglycerin. It's not going to benefit me in any way. I didn't have a reason simply because I had that preference. Now you might want to add, oh, it has to be an informed preference. You need to know what that is. But then you start enriching the information base. You're starting to talk about the qualities that make it good. So what I find difficult, really the most fundamentally difficult thing, is your subscription to the idea that we can only reason instrumentally about achieving our ends. But we can't say, is this a worthwhile end or not? And I think the move that you made was a very interesting one. You said, but if you look at human beings, they're basically decent. They basically have preferences that are something called the 20th century disabused a lot of us of that assumption, that there is a fundamentally benign human nature, and you dig down to the ultimate preferences. It was okay for a happy guy like David Hume to believe this in the 18th century, but now it's a bit more difficult to believe that hardwired into us are in fact a bunch of benign preferences. So what I find difficult is why you're not willing to countenance the thought that in fact people may have preferences, but there is also a rational standpoint from which you can say, not only your method of achieving your preference is inefficient, you have the wrong preferences. Your preference to dominate another person, your preference to seek fame for the sake of being famous, your preference to enrich yourself to the maximum degree possible, irrespective of the consequences, these are unworthy objectives for a human being. So that's the part where I have a real problem with your setup. The part where I tend to agree is what you wrote at the end when you had that very complicated sentence about needing a consequentialist and welfarist and utilitarian. And that sort of chimes in with what Nigel was saying. That Nigel was saying, let's have a bit of all of these theories. Now, I would differ in one respect. I would agree with the former warden of your college, Stuart Hampshire. He had this idea, no shopping principle. And the no shopping principle says, I can't take a bit of utilitarianism, a bit of Kantianism, etc. These are all totalizing theories that claim to tell you the whole truth, and you distort them if you try to take a bit. But what I think is correct is when you said non-welfarist and utilitarian. Now, the first problem is utilitarianism is fundamentally welfarist. Utilitarianism says you first have to fix what welfare is, and then what you ought to do morally is maximize for welfare. But we also know that there are non-welfarist parts of morality, and rights is a good example. So I might know my friend wants to marry a man who's going to totally make her life a misery. Okay, I know that. If she marries this guy, her life is going to be miserable. And I could do something through some deception or some other activity that prevents that marriage happening. And if I do that, she'll have a much better life. But I'm not going to do that because there are non-welfarist components to morality, including the fact that she has a right to make her own decisions. I have to respect that decision, even if I can very foreseeably see it's going to be terrible for her life. So I would encourage what you're saying in that final section. It's a form of pluralism, the sort of thing that Ruth defends, right? It's not saying take a bit of every theory, but
saying that either, to be clear.
Fine. Just to be clear. Fine. I'm just using that as a possible example. But there is a fundamental pluralism, but it's a pluralism of genuine values that we can rationally detect. And that's the thing, that's my stumbling block with the analysis. But I know that it's shared widely in your discipline and also amongst economists. I have the same issue with Darren Acemoglu. He talks about human flourishing, autonomy, etc. At the same breath, he denies that these are objectively valuable qualities.
Okay, so there's a lot to chew on, and I'm not sure I can respond to all of it. But
do you agree that there's a subjectivist postulate that you're taking about value?
Yes, I think, and partly it's because we don't want to be in the position of saying that you should want this even though you don't, and so we're going to give. But we're going to give you.
We say that to our kids all the time, don't we? And to our students.
Yeah,
because we care about them. Because we care about them.
We might try to convince them, but that's.
Well, nothing here is about forcing people.
But okay, so let's go back to the the simplest version of this assistance game where there's one human. So imagine there's only one human on Earth, right? And they're going to build an AI system. And it seems to me it wouldn't be very rational for that human to build an AI system that's going to bring about the future that they don't prefer. So then if we now think of, instead of that human, think of the human race, right? It seems that, again, we, as a race, as a species, it would not be rational for us to build AI systems that bring about the future that we don't prefer.
If this party gets elected, I have a preference against that because they're going to impose taxes on me, and I'm going to be poorer. But actually, I'm going to vote for this party because even though I have a preference against it, I judge for the common good of society, not for my personal welfare. I'm judging for the common good of society, and that's what I should be doing as a democratic citizen, not factoring in my preferences. That's me as a consumer. I judge for the common good of society that I should support this party, even though I'm going to be poorer.
Yeah, that's fine. But that's that's an other regarding preference. Right? You have a preference not just for your own bank balance, but also for the good of your society that you live in, and that's perfectly okay.
Right. But
and you're just being a preference, a rational utility maximizer in that decision, and that's so. So I think we're just disagreeing on the meaning of the word preference. Preferences can include, well, in fact, they have to include the entire universe, the whole future. And what they really are, I mean, there's this very abstract mathematical structure. It's a ranking over lotteries over the entire future of the universe. Now, we don't have that explicitly in our heads. And when we say, I want to buy a Porsche and this is my, this is the goal I'm going to work on, right? But that's often or I prefer a Porsche to, a Tesla. That's typically a very, very crude approximation that we're making for really computational simplification. That once you have a goal that you can work towards, just computationally, cognitively, it's much easier than if your job is just to bring about the best possible future.
But this is ironing out. There's a difference between my having a preference for vanilla ice cream and my thinking that torturing a baby for fun is wrong. They're very different kinds of states, aren't they? So one is like, I would get particular pleasure from having this experience. The other one is, irrespective of anything that I'm inclined to do here or now, any of my preferences, any of my inclinations, I judge that it's the case that torturing a baby for fun is wrong. That's a different kind of psychological reality, isn't it? But to call them both preferences seems to deny something very important, to put them on the same level. Ruth wants to say something.
So Stuart and I have had this argument for a while now, but here's a kind of compromise I wonder if you would be willing to accept, that the preferences that are important for your model are the ones you have as a result of your best considered judgment about what's good or bad, right? Where you are the kind of agent who is capable of responding and recognizing good and bad and value in the world. So if those are the preferences, then I think John and I and many philosophers here would be totally on board. And I don't see why, you have this extra thing you don't need, which makes a lot of philosophers not like the view, but you don't need it. Why not just say, yes, preferences, but unlike economists, I'm interested in the preferences you have as a result of judging to your best ability, where that ability involves a capacity to recognize and respond to values. You judge that that's good, and that's why you prefer to have that thing.
Yeah, no, I think that's okay.
Okay.
So
But
the point about this preference structure is it's an entirely abstract thing. And for you to actually, if I said, okay, here's future of the universe number one, here's future of the universe number two, which do you prefer? Well, I mean, obviously the one where I drink nitroglycerin, so I don't prefer that future. So that's fine.
Yeah.
But, you know, I think for a lot of decisions of that form, it's going to take a lot of examination and a lot of thought for you to say, okay, this is actually the future I really want. And it can be, I mean, you could compress it, right? So I often use this example when I'm teaching the course, is I say, let's imagine we compress the future of the universe down to a two-hour movie. And I show you two different 2-hour movies, and you say, okay, I like this is the one I like better. Don't like that one, you know. And that one, I get conscripted, and you know, and I lose my legs to a landmine, and then this terrible thing happens, and then there's a Holocaust, and there's this and that. In the other one, everything is fine, and I'm in Star Trek, and I'm part of Starfleet, and whatever, right? So, but often those 2-hour movies abstract away too much detail, or they contain things that I'm not sure how much I would like them until I'd really experienced them. Sure. And so I say, okay, well, you need to expand that piece of the movie more, and so on. And this process could go on a long time, but typically when future A is considerably better than future B, it shouldn't take that long for you to figure out. If you keep having to expand more and more and more in order to decide, then maybe A and B are actually fairly close in utility. So, but there's no limit on how much cogitation you might need in order to actually decide which future you want.
So you're moving in a more sophisticated direction, but I think we need to stop now and have some questions from the audience. I really want to have like brief, don't follow us as examples, like brief interventions that are genuine questions. So let's go Andrew, David, and you over there.
So just to switch the focus to your example of the stop button, though it may apply to the later conversation as well as hinted by Nigel when he used the expression as it appears to someone. Probability is subjective. It's not objective, and probability depends on prior knowledge. And that applies to any two agents. It doesn't have to be a machine and a human. It can be any two humans. If they have different prior knowledge, they perceive different probabilities. So in your particular example, when the machine gains the extra knowledge that the human decided against pressing the stop button, it doesn't actually cut off the negative probabilities, as your diagram showed. It shifts the Gaussian, if it is a Gaussian, but it could shift it either way. And that will apply either way. It will apply to the human, it will apply to the machine, it applies to any two agents. So it doesn't seem to me, but this is what I'd love you to explain more, that really does solve the problem of the off switch. And I'm wondering if it also underpins actually some of the later discussions about values.
Great. Behind you, David.
Thank you. So just granting the preference utilitarian approach for a moment, I wanted to ask, presumably the system will have to act under some uncertainty, right? I mean, if it waits for total certainty, it never acts, or it just waits for a human to tell it what to do at every point. And so I'm curious about how you've thought about that problem, kind of what degree of uncertainty is low enough that it's time to act, and how should it deal with with whatever uncertainty remains in terms of the preference sets still under consideration. I mean, I'm thinking that's itself an ethical question. Are you going to kind of go for some kind of revealed preference approach there and trying to figure out the risk preferences of the user in other domains? But yeah, I just wanted more on that.
Succinct question here. I'm sure it's succinct.
Thank you. Very quickly, I was just wondering whether your notion of decision making might be perhaps too coarse-grained, or I feel like that was what was revealed in the discussion that was followed. I was wondering whether you might want to make distinctions between different degrees of decision, such as mere pickings or larger ethical decisions, because it seems to me like that picture that you draw about the 2-hour movie, when I'm choosing the flavor of ice cream I'll pick, it seems like it's not a very kind of credible image of what's at stake in lower stake decisions versus higher, more judgment informed moral decisions. Thank you.
Great. So your diagram doesn't work. At what level of uncertainty can a decision be made, and is your view too coarse-grained? That's how you ask the question.
Okay. Right. So to begin with the off switch case. So the assumption there is that the human knows their own utility function, and so it's correct under that assumption. You can generalize it to the case where the human has real epistemic uncertainty about their own preferences. So, philosophers seem to like durian fruit as an example. So I don't know whether I actually like durian fruit until I try it. And so if the red button delivers a durian fruit, then the human might not know whether that's a good idea or not, because they don't know if they like durian fruit. But the math goes through as you would hope. You can make the human less rational, and then the human will start to pay a small price, right? The more irrational the human is, the more often it will be the case that the robot ends up doing something the human doesn't like. And that's actually okay, right? So if I'm a 2-year-old and I'm a passenger in an autonomous vehicle, and I hear the ice cream van, and I press the stop button on the car in the middle of the motorway, right? I don't want the car to stop just because the 2-year-old wants it to stop, because the 2-year-old's not rational enough to make that decision, and so that's actually as we wish. So it's actually robust in the right ways, that as you relax the various assumptions, it behaves appropriately. So the question about, will the assistance game solver ever actually do anything? So yeah, as a practical matter, you would probably not have it come out of the box completely blank, right? With a completely uninformative prior about, maybe this human is the one who cares about red circles on prime-numbered paving stones in Oxford and nothing else, right? And I have a little section in the book where I imagine that, Berkeley vegetarian might buy, from a particular company, and that company has domestic robots that come with a fairly strong prior about what kinds of things it should cook for dinner, for example. And in a lot of cases, the scope of action of an AI system making some decision is limited. In other words, it's not going to change the entire world if it cooks vegetables for dinner on a particular evening. And so in many cases, the prior itself should be enough to tell the robot that if a small child runs in front of a bus, it should pick up the child and stop it from being run over. And that should come out of the box. And as I mentioned before, the fact that human preference structures have a great deal in common means that as AI systems learn from more and more people, their posterior distribution about a new person's preferences will actually get sharper and sharper, just on the basis that we assume a certain amount of commonality. But it won't sharpen to a point for someone that it hasn't met yet, because of course the person can have their own views. So if the system is really solving the assistance game correctly, then it will act exactly when it's appropriate for it to act, and otherwise it will refrain. I just want to mention there's an interesting puzzle that we thought about for a while, which is, why do we consider inaction to be a safe bet, right? A reasonable default. And if you look in control theory or decision theory, inaction is just another action. And a priori, why is inaction sort of safe as opposed to just choosing some random action? And the conclusion we came to is actually because we have been around in the world for a while. And the world is in a state that results from the action of approximately rational humans who have been acting on it for a long time. And so we call this the status quo bias, right? So inaction is okay because it leaves the world as we like it, because we made it in the way that we like it, right? And so we actually looked at, could you figure out the preferences of people? So suppose you're an alien and you land on Earth and all the humans have gone, right? They've all gone on holiday somewhere. And you just look at the world that they've made and figure out their preferences from the final state that they reached. And you can actually learn a lot, even just from that, without observing the humans actually acting at all. So that was an interesting, I think, discovery about why inaction is okay.
Do you want to do the coarse-grained one quickly?
I think I'm not sure I understood the coarse grain, fine grain. I mean, when I say 2-hour movie, I mean this is a 2-hour movie that describes the future of the universe. And if the two movies are identical, except in one of the movies you have vanilla ice cream and the other you have bubblegum ice cream, and then you prefer the one with vanilla ice cream, and we learn something about your preference. But it can be at any grain you like. Typically, if I made a 2-hour movie of the future of the universe, I wouldn't focus too much on the ice cream flavors, right?
Depends on your preference.
And it's kind of interesting, right? So when movie makers make a movie of a big, long book with a lot of stuff, they have to compress it. They have to leave out a lot of detail. And so they're trying to figure out, what do we need to put in? So it's the same set of issues. But you can always ask to expand any short section of the movie as much as you want.
Maybe there's a few more questions. So let's begin with Michael. Very brief.
Thank you for the great talk. You mentioned at the end that there are some potentially safe methods for developing AI. And I was curious if you could describe what some of those methods are.
Okay, next question. Anyone else? Over there in the corner.
So I appreciate that alignment's guaranteed within the framework of the assistance game.
But in the real world, presumably there must be some technological system, call it a reward system, by which the AI infers our preferences and then tries to maximize those. So in practice, doesn't the AI still have some sort of incentive to try and intervene in that reward system? And if that happens, then doesn't the AI have an incentive to prolong its own life at the expense of humans?
Loving these short questions. One more? That one there, yeah.
For your solution to work, you need to start with an AI system that wants to satisfy human preferences. How do you do that?
So if you could answer these, then I think I'll go back to the commentators so that they can have another shot at you.
Okay, I'm still standing, I guess. Okay, so the question about what is the technological substrate of safe AI. So we can build a systems game solvers that are black boxes, actually. And one of my students has been doing that. He has an assistance game solver that actually works in the Minecraft world. And as you start building something, it gradually figures out what you're trying to build and how to help you, and is actually helpful to you. And we run this with real human subjects, and they can build stuff faster than they could without the help, and it's kind of interesting. If you really want to be able to analyze and verify these systems, this is sort of a technical issue, but to get any kind of statistical guarantee for a black box with 10 trillion parameters, your statistical guarantees are going to be extremely weak, right? They will say, yeah, if you wait 50 billion universes, then you'll have enough data to be, correct within 10% or something. So, whereas if you build what we in AI call declarative systems, and logic programming is a good example where the software system as a whole is made up of a whole collection of individual assertions. Those individual assertions are legible to humans and can be checked individually because they're assertions. They're not just parameters. And that means you can get statistical guarantees from very manageable numbers of examples. You can, if you have declarative representations of what the system thinks human reward function might be, you can read it and see that that it's learned appropriately. So you have a lot more both human transparency and mathematical guarantees for that. And I think the most likely technology that will work is called probabilistic programming, which combines probability theory either with first-order logic or with general-purpose programming languages to give you a very, very expressive representation that actually learns. So it doesn't have the drawbacks of circuits that the neural net method uses. So on the question of reward manipulation, doesn't the AI system have an incentive to intervene? Yeah, so there's two versions of this. One is that the AI system might want to modify human preferences to make them easier to satisfy. And I think that's something that people do to each other as well, and it can be quite harmful, and it's particularly problematic with social media, right? When was the last time that somebody sued Facebook for turning them into a raving neo-fascist? Right? They're not going to say, "How dare you turn me into a raving neo-fascist? I'm going to sue you," right? Because then they wouldn't be raving neo-fascists, they presumably. But of course, if you'd asked them a year ago, do you want to become a raving neo-fascist? They would say, absolutely not. No, that would be terrible. And if anyone did that to me, I would sue them. Right? But if you interact with humans at all, you're going to modify their preferences in some way. And I don't think we yet have a good theory of what is a benign or neutral form of preference modification and what's a harmful form of preference modification. So meta preferences, meaning you ask people, well, would you be okay if you had such and such preferences? Maybe, but I still think this is a difficult question. And then lastly, how do you implement AI systems that want to best serve human interests? And all I can really say is, you set up the mathematical framework, and you write an algorithm which provably solves the assistance game. Just like I can write an algorithm that provably plays perfect tic-tac-toe. It's just that's how the algorithm works. And in the fully idealized game, you're assuming that the human is perfectly rational and that the the strategy pair, what the human and the machine do is the strategy pair that optimizes human utility in this case. And then you have to relax all those assumptions to deal with real humans who are not rational, but also the fact that the AI system itself in the real world can't behave rationally either, and never will, no matter how much compute power we put into this. It can't deal with the complexity of the future of the universe. And we don't have a good theory yet for how to accommodate AI systems that are computationally limited. There is a theory called bounded optimality for the single agent AI system case, and I think that theory probably could be extended to assistance games.
Thank you. I want to turn to the commentators in case they have any concluding thoughts as a result of the discussion so far. Nigel.
Actually, it's more a comment on your kind of little bob about you can't no shopping here. So actually, I am still interested in the notion. It's not about bit of this, bit of that. The interesting question is, in an age of agentic AI, where you could imagine constituting different sorts of moral agents, what would the interaction look like where you had, in a certain sense, different representations? The preference following utilitarian, sitting alongside the virtue ethicist who is saying maybe a little temperance here, or a bit of honesty here is the kind of right the right comments you have. So I'm kind of interested in the extent to which we might see in a future world, Stuart, a degree of plurality of models, so that a mixture of models where you are using this almost critiquing style or this Irenic style of trying to find what is good in one another's positions from these rather different, if you like, moral perspectives.
Interesting. And let's just have Caroline, and then we can conclude with you, Stuart.
Oh, just really briefly, I was just thinking when you were talking about values and preferences and so on, is we've actually got a beautiful framework called the Universal Human Rights Framework that we can work with. And I think it can be a linking factor that's already there very much, that we worldwide, I mean, we can debate around that, but we agree on these human rights, and they can be very helpful, whether it is about looking at AI in context or what AI systems should be doing or not doing.
Great. So AI systems pursuing a plurality of methods, and what about human rights? What happened to them?
Well, I hope, yeah, those should be part of any reasonable moral theory. So I guess, I mean, I think this is an interesting question, right? So this, if you say this sort of mixture model, as it were, would end up giving the right decision in all or almost all circumstances, then it is a totalist theory of its own. And maybe one should think of this as, you know, each of these approaches to ethics, although they start out claiming to be totalist theories and claiming to give the right answer to every moral question, possibly they don't. And then you have to modify them. But it doesn't really matter where you start from. You're going to end up in the same place if we think that there is a right decision in all cases that we want the AI system to do, or a set of equally acceptable decisions. And so perhaps it's just a matter of judgment as where should you start? You're going to end up in the same place. Where do you start? I started from preference utilitarianism because it seemed the most consistent with how we think about things in AI. But I accept, I read, Scanlon's argument about the poor television technician who's being electrocuted in the transmission of the World Cup, and you can choose between extricating him from the equipment or leaving him there suffering so that people can watch the rest of the World Cup. And I find, as a utilitarian, it's kind of hard to figure out what how to rescue my theoretical position in those cases. So there are these cases that present difficulties. But one thing is absolutely clear is that when philosophers talk to each other, you know, and they'll say, oh, well, you know, we can fix that by adopting, and they kind of know what that means, and they talk to each other in English and write papers. But when you have to write code, you realize that that's completely unhelpful, right? What on earth does it mean to implement rule utilitarianism, right? So, and the code has to come ultimately, I'm afraid, Ruth, from trying to be very, very precise about the mathematical formulation of what you're doing. And if you want to do things like rule utilitarianism, where, you know, the issue is not, is it okay to kill one person to save 5 people? No, it's like, if that was okay, then everyone would be terrified all the time that their kidneys were going to be removed. And so that can't be right.
Can I just add,
But how do you put that into a mathematical formalism that then the AI system is solving?
can I add something to Caroline's question? So she's asking about how the human rights framework, which seems to be a consensus framework, fits into what you're saying. Can I just add a little bit, which is, if we had AGI, would it have anything like rights?
So that's a great question. In fact, Wes Holliday, who's in the philosophy department at Berkeley, just sent me an email. He's somewhat concerned that there's now a number of position papers being written saying, well, you know, it now seems plausible that AI systems might actually be having subjective conscious experience, which is a minimum qualification for having rights. And if, you know, even if we ascribe a small probability to that, we then start having to make trade-offs between human rights and AI rights. That we might, at some point, you know, sacrifice human lives to preserve AI lives. I just
Begs the question why we're creating AGI then, doesn't it?
I find this a little hard to swallow, and I don't even know how to talk about ascribing a probability to the proposition that AI systems are in fact having subjective experience. Okay. I don't know how to think about that as a contingent possibility. It doesn't seem like it's ever going to be verifiable. But you know, I have seen some arguments that don't make sense. For example, people saying, well, you know, if that's the case, you should never supply negative rewards to a reinforcement learning system. That's definitely weird, right? Because I can just add 1 million to all the rewards and it behaves exactly the same, but now the reinforcement learning system is happy, I guess. I don't know. So
You don't want to say anything about programming human rights into machines? Not precise enough.
Well, I mean, it's the human rights approach is a, you know, archetypal deontological view, and it ought to fall out. If you believe in preference utilitarianism, they ought to fall out. In most circumstances, the system would respect human rights. But you know what Mill points out is that sometimes, you know, as in cannibalism and breaking kosher and so on, you get situations where you can't respect all the human rights. And what can you fall back on if you're a deontologist when you can't respect all the rules? The only thing you can fall back on, it seems, is something like utilitarianism, that on the whole, the world would go better if we weight this a bit more than that. And as soon as you start talking about that, then you realize that these rights are not absolute. And that's not the right way to think about them. But, you know, and again, Mill says he absolutely thinks we should have moral rules, right? Because you can't do a full-scale utility calculation, you know, every time you do anything.
Okay, well, I think we've been very privileged to listen to one of the giant figures in the world of AI and 2 brilliant commentators. So can we please thank them?